In today's video, we are going to explore the pH scale and gain a deeper understanding of what acids and alkalis are. The term pH is essentially a way to measure how acidic or how alkaline a solution is. This measurement is done using a scale that ranges from 0 to 14, where lower numbers indicate higher acidity, higher numbers indicate greater alkalinity, and a pH of 7 represents a perfectly neutral substance. Neutral substances are neither acidic nor alkaline, and pure water is a classic example of this, sitting right in the middle of the scale at a pH of 7. To help give you a clearer sense of what these numbers mean in real life, consider this: the acid in your stomach, which plays an essential role in killing harmful bacteria and helping digestion, typically has a pH of about 2, making it very acidic. Acid rain, which is harmful to the environment, has a pH of around 4. On the alkaline side of the scale, household cleaning products such as washing up liquid have a pH of around 9, while stronger substances like bleach, often used to disinfect bathrooms, have a pH near 12. These examples are provided to give you a frame of reference, but do note that you do not need to memorize these exact values for exams. Now, when it comes to measuring pH, there are a couple of reliable methods. One common approach is to use an indicator, which is a type of chemical dye that changes color depending on the pH of the solution it is placed in. Different indicators will exhibit different color changes at different pH levels. Some indicators are composed of a mixture of several dyes and will gradually shift color across a wide range of pH values, and these are referred to as wide-range indicators. The most well-known of these is called universal indicator, which displays a spectrum of colors corresponding to the pH scale, ranging from a deep red for very strong acids to orange and yellow for weaker acids, green for neutral solutions, and then blue and purple for increasing levels of alkalinity. The second, and often more precise, method to determine pH is by using a pH probe that is connected to a pH meter. When the probe is immersed in the solution, it electronically measures the pH and displays a numerical value on the digital screen. This method is particularly useful because it eliminates the need for human judgment and color comparison, which can be subjective and imprecise. As a general rule in science, the fewer decisions left to human interpretation, the more reliable and accurate your measurements are likely to be. Now that we understand how to measure pH, let's take a closer look at what actually makes a substance acidic or alkaline. Acids are substances that, when dissolved in water, produce solutions with a pH lower than 7. The reason acids are acidic is because they release hydrogen ions into the water, which increases the acidity of the solution. On the other hand, bases are substances that have a pH greater than 7. A special group of bases that are soluble in water are known as alkalis. So we can say that alkalis are simply bases that dissolve in water to produce solutions with a pH above 7. These alkalis release hydroxide ions, which are negatively charged ions represented by the symbol OH-, and these ions are what make the solution alkaline. When an acid reacts with a base, we get what is called a neutralization reaction. In these reactions, the acid and the base cancel each other out, and the products are always a salt and water. For example, if hydrochloric acid reacts with sodium hydroxide, which are two of the most common acid and base respectively, the reaction will produce sodium chloride, which is a salt and water. We can also describe this reaction in terms of ions, where the hydrogen ions from the acid and the hydroxide ions from the base combine to form H2O, which is the chemical formula for water. Because both the acidic and alkaline properties are neutralized during the reaction, the resulting solution should have a pH of 7, indicating that it is neutral. Before we wrap up this video, let's quickly go over some of the common acids and bases that you are likely to encounter throughout your chemistry course. The three main acids you should be familiar with are hydrochloric acid, sulfuric acid, and nitric acid. As for bases, many of them are either hydroxides or carbonates, with common examples being sodium hydroxide and calcium carbonate. While there are many more acids and bases that exist, these are the key ones that come up frequently in questions, experiments, and real-world applications, so they are definitely worth remembering. Anyway, that brings us to the end of this video. We hope you found it informative and enjoyable. If it helped clarify the topic for you, please consider liking the video and subscribing to the channel, and we look forward to seeing you again next time.